Okay, let's start. So today we were supposed to start the the sixth chapter, that was linear equations in one variable.
Ma'am, chapter
Okay.
6 is the last backup class, I think.
Um, Chapter six is the last complete chapter backup, but I'll also see if there needs to be kept a
Ma'am, I
backup.
ma'am, I joined when ma'am, I joined when chapter 6 was taken. Right.
Six was taken. Okay, Andre. Anaya
Chapter
and
7 or middle of chapter
seven.
I
And
think
Anaya
Anaya joined in
joined in
chapter 7.
seven. Abraham joined in
7, I
mid
think.
of chapter mid of chapter seven.
Yeah, I joined from chapter 7. Abraham.
Abraham joined from the proportion part of the chapter seven, right? It's ratio and
Mom, he
proportion.
joined from chapter 8.
No, chapter 7. Chapter 7.
Abraham, when did you join it up?
Chapter 7.
No, Mom, Abraham.
In the middle of
July 1st.
Middle of chapter seven. Yes, the proportion portion you joined. Okay. I'll see if I'll take a backup of that. Okay, I'll let you know.
I don't think so. I think chapter 6 is the last backup class.
Okay, if Abraham needs or if y'all needs a revision, y'all need a revision of the chapter, the ratio proportion chapter, then just let me know. I'll plan it. Okay, that, but it will be after your holidays. Okay. Yes. Now, let's begin with the sixth chapter. That is linear equation in one variable. Linear equations in one variable. Now, in the previous chapter, we saw algebraic expressions, right? We saw some algebraic expressions. A linear equation is made up of an algebraic expression, but it is equated. Okay, means that linear equation is complete.
Ma'am, they
Algebraic
have
expression,
equal sign.
yes, they have equals to sign. Okay, they are complete. Suppose if I write 22x minus 1, this is what? An algebraic expression. But if I say equals to 0, equals to 0, then this becomes a linear equation, a complete equation. What's the meaning
Ma'am,
of linear equation? Yes, Cedric. In one variable. One
ma'am,
variable.
one variable means there's only one variable in this whole equation, like x, y, z. Only one of them will be there.
Yes, that's right. Only one variable will be there in an equation.
Then two
Okay.
variables.
Two variables is called linear equation in two variables. But this chapter, we have only one variable we are going to study. Okay, linear
Ma'am, it's
equation
called
in.
linear equation because the highest power is 1.
Yes, highest power is one. We'll
The
come to
degree is
that part.
1. The degree is 1.
Yes, we'll come to the part where we'll talk about the degree, but right now let's understand its meaning. Can I have your videos on, please? All of you, Abraham, Anaya, Simeon. Videos on, please. Yes. So, now, what's the
Ma'am, my
basic?
network is low, so I'll have to keep my video off.
Okay, that is not a problem, Anaya. Network is low, you can keep it on. Okay, yes. So, now, what's the basic form of a linear equation in one variable? Okay, its basic form is ax x plus b equals to
0.
0. Okay, where
Ma'am,
x is our variable. Yes,
ma'am, there are 3 variables here, a, x, and b.
yes, but a and b are real numbers. Okay, x is the variable. Here in this standard form of linear equation, a and b are real numbers and x is the variable. Okay, so let's write the definition of it. Let's see the definition of it. Linear equation is basically, like I said, an equation which has a maximum of one variable, okay, or only one variable of order 1. Now, it is in the form of ax plus b equals to 0. So, you can write it down. An equation which has maximum of one variable. It is in the form of ax plus b equals to 0. Plus b equals to 0. Okay, now this is ax plus b equals to 0 is known as standard form of linear equation in one variable. Okay, standard form of linear equation in one variable. Okay, now there are two things about it.
Ma'am, what is
That
order 1? Order 1.
degree, basically. Okay,
Degree
degree 1. Yes. Now a and b are real numbers in the above equation. Ax plus b equals to 0. A and b
They are
are
numbers.
real, yes, real numbers. Okay, and a and b are not equal to 0. Both a and b are not equal to 0. 0 and x is the variable. Okay, so here, don't think that a, x, and b three variables are there. No. In this standard form of linear equation, a and b are not variables. They are real numbers. X is the variable. Okay. And why? And its degree is 1. Okay, why? Because x will always have the power of 1. Okay. X
Ma'am,
will always have, yes, Andrew.
so if the highest power is 1, it is called a linear
Yes.
equation. Then if the highest
Highest
power is
power.
2. 2.
That is called linear equation in two variables.
No.
Sorry,
Highest power is 2.
equations in two variables.
No. The highest power is 2. One variable only.
Variable will be 1. Yes. Two variable. Okay. Yeah. Two variable is when we have two variables like x and y both. Okay. But linear equation in two variables, still the power remains 1.
But the equation with the power remains 2. The equation is That's 2. Then
Yes, variable becomes 2. Okay, that we don't have right now two variables or the exponential power of 2. We are having linear equations. We are having equations with degree of 1. Okay, that is only power will always be 1 in this case. Okay, now have you written the definition? We'll take a look at some more examples.
No, ma'am.
Yes, ma'am, done.
No, ma'am.
Okay, you can write it down, Abraham. It's okay. For example, 3x equals to 1. Okay, now 3 and 1 are the real numbers. Okay, 1 is the answer. Okay, and x is the variable. Okay, this is a linear equation because only one variable is there, that is x. Then 4x plus 9 equals to minus 11. Okay, which is another linear equation where x is your variable, 4 and 9 are real numbers, and minus 11 is the solution of your equation. Okay,
ma'am,
so this is, yes, Andrew.
ma'am, for the first one, x equals to 1 by 3, and for the fourth one, x equals to minus 5.
First one, x equals to, can
1
you
by 3.
repeat? 1 by 3.
Yeah, 1 by 3.
Okay. And the second one, x equals to minus 5.
Minus 5.
All right. So these are some examples of linear equation. Okay. Also, one very important thing, they have only one solution. Okay. We can say that they have only one solution. Why? Because only one variable is present. We can obtain only one solution. Now, three things I will be explaining you in this chapter as we move forward. Okay. One is one is like creating the equation when we are given the statement, forming an equation out of it. Then the second that you need to practice is when you are given an equation, how do you form its statement? Okay, how do you form its statement? And the third thing is how do you solve a linear equation?
Excuse me, ma'am.
Yes, Sarah.
I didn't understand the example now.
Which example, Zara? These two?
Yes.
Okay. Now see, Zara, the first example is 3x equals to 1. Okay. Now, 3 linear equation in one variable means the equation will have one variable. Okay. And it will have an equals to sign. It will be a complete equation. Okay. So, x is only one variable here. Okay, these are just examples. You don't have to solve them right now because I'll be teaching you how to solve them. Okay, so x is one variable in this equation and it is a complete equation. 3x equals to 1 with an equals to sign. So it is a linear equation in one variable. Then the second equation, 4x plus 9 equals to minus 11. Okay, again 4 and 9. This equation, second one, is completely in the form of ax plus b equals to 0, the standard form. Right. So here 4 and 9 are real numbers. Okay, x is my one variable that is put there and minus 11 is my solution. Again, it is the complete equation. Okay, complete equation. So it is linear equation in one variable because only x variable we have. Okay, if in an equation you are having more than one variable, that is, you're having x also, you're having y also. Okay, take a look at this equation I'm writing 2x plus 3y equals to 14. Okay, it is also
Then
an
there's
equation.
two variables.
Yes, because equals to sign is there and a number is given. This is also a complete equation. But again, this is an equation in two variables. Why? Because x is also given, y is also given. Two variables are given, so two variables. But that we don't have. We are having right now
But
in one.
if it was only 2x plus 3, then it would be only one variable, right?
Ma'am,
2x plus 3 will be an algebraic expression, Simran, because doesn't have an equals to sign and a number after it.
No, it's 2x plus 3 equal to 14, like that.
2x plus 3 equal to 14 if it was, then it is linear equation in one variable. Okay.
Ma'am,
If it is not equal to 14,
That's what I
yes, if equal to
ma'am,
14
x
is
equal
not
to
there,
11 by 2.
then expression. Yes. Yes, Abraham.
I'm not Abraham.
Abraham has asked something, so I was asking him again.
if we solve this equation, ma'am, if we have the value of x, ma'am, then we just have to multiply it by 2 to get 2x. Then subtract 2x from 14. And then the remaining part divided by 3 to get the value of x.
2x plus 3 equals to 14, you were telling, right?
Yes, ma'am.
Yes, we take 3 this side, okay, because number on one side and variable on the other side. Okay, so it becomes 14 minus 3. Okay, 14 minus 3. We'll subtract 3 from 14 and we'll get 11. And then we'll take 2x equals to 11. So x
No, ma'am.
equals
No, ma'am. There's a y. 2x
so
plus
that
Plus 3. This is a y.
this is in one variable. Okay,
ma'am.
you were telling about two variables.
How to solve in two variables?
Two variables.
I want to solve two variables.
Mhm.
Suppose 2x plus 3y, and I know that 2x, I know the value of x. Then I can multiply x by 2, which will give me 2x. And then x, subtracted by 14, will give me the answer to 3y. But if I want to find out the variable y, I will do that answer divided by 3.
Yes, Abraham, you are correct. Yes, you are correct. That's right.
I understood, ma'am. Thank you.
Okay, Zara. Yes. So I'm clearing the screen right now because we are going to try out some questions. Okay. Okay. Now let's see how we can convert a statement into equation. Okay. Statement to equation. You should know how to convert a statement in an equation and how to write a statement of a given equation. Both the things. Okay. Right now we will convert this statement in an equation. Statement is an integer increased by 5 by 5 equals 20. An integer increased by 5 equals 20. Okay, so what do? See, now when we are given an integer,
Plus 5 equals 20.
yes, that's right. Okay, x plus y equals to 20. So the unknown value that we don't know, we'll assume it as x. Okay,
Ma'am, so will it be x plus 5 equals 20?
yes, x plus 5 equals to 20.
And then
Assume
x
the
equals to 15.
Ma'am, the answer is 4. That variable, the integer is 4, is because 4 increased by 5 will equal to.
Ma'am, is it increased or multiplied? Increased by 5 means plus. Could
Ah,
it
yeah,
be
increase is plus.
I think
Abraham, you
the
thought it was
unknown
into.
value is
plus?
Plus, not into.
Then
Yes.
Exactly.
x equals 15.
15.
15, yes, 15 is right.
50.
Okay, so we've assumed the unknown value as x. Now, increased by 5, increased by 5, it will become x plus 5. Okay, then equals to 20. So, equation will become x plus 5 equals to 20. How we solve it? We will take the 5 on this side because again, variables on one side, numbers on the other side. X equals to 20 minus 5, which
15.
is x equals to 15. Okay, like this, we can derive an equation from a statement and then solve it. Okay,
Done, ma'am.
okay,
Finish copying.
ma'am.
okay,
I'm not done.
Ma'am.
okay. You can do some here. Okay, we'll wait a minute.
I'm done.
Done, Samir? Okay, 1 minute. Yes. So next up, we have if we are given the equation, how are we going to write its statement? Okay, if we are given an equation, how will we write its statement? Okay, now the equation is you have to convert the equation to a statement. Equation is 5x equals to 25. 5x equals to 25. Think a little and then convert it.
Ma'am,
Yes, Andrew.
ma'am, an integer multiplied with 5 equals 25.
any integer multiplied with 5 equals 25. Okay, we can write it like that. Anybody else wants to say?
Ma'am, and x equals to 5.
Yes, that's good. Yes, Simeon?
X multiplied by 5 equals 25. Or you could say that 25 by 5 equals X.
25 by 5
But
equals
how is
x.
that a statement?
Yes, but in statement form
So
that we
25
without
divided by 5 equals
You have to write a sentence.
You can't use X in a statement.
It's a sentence. So you can't use x like you have to use an integer multiplied with 5 gives 25 like that.
Or a number multiplied by 5 equals 25 like that.
Yeah.
yes, a number or an integer. Okay, you cannot put x directly and you cannot like write it in an explanation form like that. Okay, that x divided by 5, 25 divided by 5 equals to x. No, all right. Yes, we can write an integer 5 times an integer equals 25. Okay, or 5 times the number equals 25, like that. Okay, 5 times a number or integer equals 25. And if we solve this, 5x equals to 25, x equals to 25 by 5.
Is the answer 5?
Yes, Sarah, correct answer is 5. Okay, so this is how we can convert the equation into a statement. Okay.
Finish copying, ma'am?
Yeah, you
Done,
can
ma'am.
copy. Done. Okay. Okay. All right. So I'm going to give you all some practice questions. Okay. Give me 1 minute. Yes. Write the statement in equation. Three times the number is same as adding 2 to the number.
Ma'am,
Yes.
when is it 3x equal to x plus 2?
Yes, that's
And x is equal to 1.
x equals to 1. Yes. You're correct. One more. Okay, trick. This
Just give me a
time,
minute.
yeah, sure. This time, please don't answer at the beginning, okay? Let everyone do it and then we'll discuss it again. All right?
Done, ma'am. Thank you.
Done. Okay. Yes, 3 times a number is the same as adding 2 to the number. What do we don't know? What's that we don't know? The number. So we assume the number as x or y, any variable of your choice. Okay, but just keep it one variable only. Okay, 3 times the number is same as adding 2 to the number. So 3 times a number, any variable, 3 times of that variable will be equal to that variable plus 2. Okay, so if I assume that my variable is x, so my answer will become 3 times x means 3x equals to adding x to the number. What did I assume my number as? X. Adding 2 to it, x plus
X plus 2.
2. Okay.
Ma'am,
Yes, Edwin.
ma'am, it is x plus 2 and not y plus 2 because only one variable is there.
Yes, only one variable is there. Same variable is there in the equation. So only x we are gonna use. Okay. Now one more question for you all to try it out. Okay. We'll discuss the answer only after all of you have done this. Done. Okay?
I finished.
Width of a rectangular garden is half of its length.
Done.
And perimeter is 600 meter.
I know.
I know.
Unmute yourself and do it.
Ma'am,
Yes, Arjun.
okay, so the perimeter is 600. No,
600.
I mean that is
600.
perimeter is 2 into L plus L plus B. And B is half of L. Okay, ma'am.
Ma'am, I got the answer.
Got the answer. Everyone is done?
I mean, I think I got it.
Okay. Zara Abraham done?
Ma'am, I wasn't able. Wasn't able to.
Okay, no problem. We'll discuss. Okay. Yes. Now you can tell what answers you got.
Ma'am, I got the width of a rectangular garden is 150 meter and its length is 300.
Anaya, your voice is breaking a lot for me.
Ma'am,
I cannot hear you.
ma'am, I got width as 100 and length as 200.
Width is 100, length is 200. Correct. And how, what equation did you make?
Ma'am, I use a 2 into this one, 2 into L plus B.
2 into L plus B. Okay. And Samir?
Width is 100 meters and length is 200 meters.
Length is 200 meters. Good. Okay, so we can use 2 length plus breadth. Also, we can use this equation as well. Okay, now, 1 second. Yes, see Zara, we are having two things here, length and breadth. Two things we are asked. Okay, so let's assume that the width is x. Okay, let's assume that width is
X.
x. Now it's saying that width is half of its length. So length,
Length is 2x.
we can assume 2x. Okay, and rectangle has two lengths and two widths. If we add them all together, it can we can find out the perimeter, or we can use Edrich's method as well. Okay, two length plus breadth. All right, so if I put them all together according to the formula, okay, I'll add the widths and I'll add the lengths. Okay, two widths I'm having in a rectangle, two lengths I'm having. So I can do x, a width plus a length 2x, then another width x and another width 2x equals to the perimeter 600. Okay, now solve it.
Ma'am, I got x equal to 100.
Yeah, this is correct, Samir. Okay, no problem. You can use either way. Okay, you can do two lengths plus breadth, or you can do that you can add up the two lengths and the two widths. Okay, equals to the perimeter. No problem in that.
Ma'am, it can also be as 2x plus x plus x, right? It can be that way.
Yes,
It can be that way.
Yeah.
Yes.
Six x.
Done, ma'am.
Done, finished
Ma'am.
copying, and 6x. Ma'am, 6x.
Yes, Edric. Please let her do it. 6x equals to 600. Now you divide the 600 with 6. Our width is 100. Okay, and length is 2x. So x is our width, length is 2 of the width. So length can be 2 into x, that's 2 into 100, which is 200. Okay, length. This is the width. Clear, Zara?
Yes, ma'am.
Okay, sure. Like if there's still any doubt, you can ask, okay?
Okay, ma'am.
Yeah. All right. So we have like this is how we make the equations with the given statements. Okay. Next class we'll practice to solve some more linear equation with one variables. Okay, and we'll see, we'll learn its verification also. That we are going to do tomorrow. Right now, we stop here. Okay, that's all for today. And please prepare chapter 5th. Okay, math test of the 5th chapter on Friday. Okay, that is this thing, algebraic expressions chapter on Friday. Okay, you can ask your doubts tomorrow or Friday anytime.
Ma'am, could you repeat the exercise you told us to practice from?
Chapter 5 you have to practice. Okay, and from this chapter, exercise 6.1. Okay, exercise 6.1. You just have to give 3 examples of algebraic equations. You have, sorry, a linear equations and one variable. You have to give 3 examples of it. That's the homework in 6.1. Okay. Okay, then see you both in the next class. Bye.
Bye, ma'am. Thank you.
Bye. Bye. Yeah, Drake. See you in the next class. Why have you logged in with 2 devices?
No, ma'am, that's Simeon.
That's Simeon.
That's Simeon. Simeon, what is this?
That's not me, that's Simeon.
Turn on your camera, Simeon.
This is Simeon. Why did you change my name to me?
Change my name to me. Simeon, what is it?
Eric,
You
he's
distract.
what you did in English class.
Yeah. Simeon has been distracting since the last 5 minutes. I'm saying why. Edric has joined with
Ma'am,
devices. Yes.
ma'am, I once joined with the name. I don't know why ma'am keeps her classes in the evening.
Yeah, you guys really need to stop all these things, okay?
No, ma'am, it's not important.
It's a live class.
Haha.
Okay then, Edric. See you in the next class. Bye.
Bye, ma'am.
Bye. Okay, 2 minutes break, thanks. And then we'll begin with the science class, okay? 2 minutes break. Okay, we are going to start right now. Hope you all are there. Can I have your videos on, please? And Abraham, videos on, please. Yes. So what were we studying in the last class? Anyone?
I forgot. Because I was thinking about the electricity and then I realized it was actually a test.
You forgot? Okay. Right. It's okay, Simran. That's fine. In the last class, we talked about water cycle. We talked about the formation of clouds. We talked about how preventive measures, what preventive measures we should take to, in the cases of, in the conditions of natural calamities, natural disasters, right? In storms, what we should do when we are having this earthquakes and all thunderstorms, what we should do, right? We talked about the preventive measures of um, thunderstorm, okay, and the water cycle, right? One small clip I want to show you of the water cycle process, okay? I'll show you that from the water cycle process. Just give me 1 minute.
Let's look at the science of rain and how raindrops form. First, we'll need the sun. When the sun shines on water on the Earth's surface, the heat of the sun warms the water, turning it into an invisible gas called water vapor. This process, the changing of water into a gas, is called evaporation. Because gases are lighter than liquids, water vapor rises up into the sky. And the further you move up and away from the Earth's surface, the colder the temperature gets. So in the sky, the water vapor cools and changes back into tiny water droplets. This change is called condensation and is the opposite of evaporation. Clouds are made up of tiny water droplets, so when condensation occurs in the sky, clouds form and grow. Let's take a closer look. When water droplets bump into one another, they stick together and grow in size. They continue to grow until they are too heavy and fall as rain. They even grow as they bump into one another on their journey from the cloud to the ground. And every single raindrop that reaches the ground is made up of 1 million of the original tiny water droplets. Raindrops fall on the ground surface where the sun can shine on them, and the whole process happens again. This is called the water cycle and keeps water moving from the ground to the sky, providing the water needed for plants, animals and people to survive. So now you know.
Okay. So this is how basically the water cycle is happening, right? Like the cycle, it keeps on revolving, it like keeps on repeating itself, this cycle. So we get the rain. Okay. Just 1 second. finished till here. Preventive measures in a thunderstorm. Right. So, and before that, we studied about thunderstorm, cyclone, bad effects of flood and drought also we did. Okay, and air currents I taught you all. Okay, the air currents and the high pressure and low pressure. Okay, so this is basically the reason why cyclones are formed. Okay, due to the air pressure. Now, tell me, do you want to watch a clip once again to like understand, to have a view better of how cyclone formation takes place?
Oh, that's fine.
Okay, Simran Abraham. Yes. Okay. I was seeing and I found this really good video, a really good clip about the formation of a cyclone. Okay, so let's see. Okay, it will give you all a revision of this topic, the air currents, the zones of the earth that we studied about. Okay, the three zones and everything. It will give you all a good revision. Okay, so let's do it. 1 second. Just 1 second.
In this video, we're going to learn about region. It is the first thing you need to understand is that tropical cyclones originate over oceans in tropical areas and coastal regions. If you all know, this is the tropical region. It is the region of the earth near to the equator and between the Tropic of Cancer in the northern hemisphere and the Tropic of Capricorn in the southern hemisphere. Tropical cyclones are known by different names depending on the region. In the Indian Ocean, they are known by simply cyclones. If you go to the Western Pacific side or near the South China Sea, it is called as typhoons. Likewise, near Western Australia, it is known by willy-willies. All these are different names refer to the same type of storm. You must be knowing this, that tropical region receives the most solar radiation per area. And the reason behind that is due to the incoming solar radiation that are direct and vertical at the tropical region. And as you move towards the polar region, the angle of the sun rays are not vertical, they are slanting rays. Vertical rays of sunlight are more effective in producing light and heat than slanting rays. And that's why the tropical region is warm. Now that you have understood the main things about the tropical region, let's understand about wind movement. Wind movement is determined by low pressure and high pressure systems. It is the differences in atmospheric pressure that creates pressure gradient and makes the wind move. And wind always blow from the areas of high pressure to low pressure areas. Now the next question is, what causes low pressure and high pressure? Low pressure occurs when air is warm, either from being over a warm land or ocean surface. That means low pressure occurs at a place which is warm. And how does a place become warm? Because of the incoming heat from the sun. That is why tropical region is a perfect place where low pressure occurs. Similarly, high pressure occurs when air is cool, either from being over a cool land or ocean surface. That is why in the polar region, that is your north and south pole, it is a high pressure zone. And always remember, winds blow from the areas of high pressure to low pressure areas. While all of this happens, there's another important phenomena which comes into the picture. It's called Coriolis force. Due to the rotation of the earth rotates towards the east, and that's why the sun, moon, planets and stars all rise in the east and go towards the west. Anyways, due to the rotation of the earth, there is a force that is generated, and it acts perpendicular to the direction of motion and to the axis of rotation. In simple terms, when the Earth is spinning in its axis from west to east, and we also know that Earth is a sphere and it is much wider in the middle. As a result, the speed of the surface of the Earth at the equator is much faster than the speed at the poles. So if anything has to come straight from the poles towards the equator, it gets deflected to the right in the northern hemisphere and to the left in the southern hemisphere. And this force that we are talking about is called Coriolis force. It causes fluids like water and air to curve as they travel across or above the Earth's surface. Due to Coriolis force, the air in the northern hemisphere gets deflected to the right side. Now you might think, no, that is going towards the left side. But then I said the air is going to curve to the right side in the northern hemisphere. To clear your confusion, you have to actually see it from the direction in which the wind is moving. So what I'm going to do is I'm going to rotate this picture and now put yourself in the path of the wind. Now you will be able to see that the air in the northern hemisphere curves to the right while moving from high pressure to the low pressure area. Similarly, in the southern hemisphere, the air is deflected to the left side while moving from high pressure to low pressure area. In this case, we don't have to rotate the picture. Now that you have understood why the air moves to the left and right due to Coriolis force, just remember this point, that it is because of this reason there are certain pressure belts all over the Earth's surface. You must be familiar with this global wind circulation pattern. You can see that at different latitudes there are different pressure belts. Their existence is simply due to the movement of air to the left and right due to Coriolis force. I hope so far you have understood the general movement of air. Now let's understand how does air turns into a storm and what causes the spinning of a cyclone. When you look at the movement of a cyclone, at the center of every cyclone or hurricane, you will find an area of low pressure, which attracts the cool air. Since we know that air moves from high pressure area to low pressure area, that means the outer area of a cyclone consists of cool air coming from high pressure area, which surrounds the central low pressure area. This region is called the eye of the storm or center of the storm. The low pressure region is a warm region where the air is warm, which expands and then rises. The cool air from high pressure zone rushes in to fill the void left by the rising warm air. This air warms and becomes moist as well, allowing it to rise. Then more cool air rushes in to fill the void. The warm, moist air cools as it rises higher into the atmosphere because temperature drops with increasing altitude. That is also how clouds are formed. Now this process continues again and again. As a result, you will see an eye-like figure at the center of the storm. Now comes the Coriolis effect. In the northern hemisphere, the cool air rushing towards the center of the storm is deflected slightly to the right. But keep in mind, the cool air keeps getting attracted towards the center because that's where the warm low pressure zone is. While moving towards the center, the cool air keeps getting deflected. Now this creates a spin in a counterclockwise direction. In the southern hemisphere, the Coriolis effect moves air to the left, opposite to what happens in the northern hemisphere. As a result, the spinning of the cyclone is in a clockwise direction in the southern hemisphere. Tropical cyclones are intense, and in the beginning we have read that it occurs over the ocean surface and coastal region because there is a continuous supply of moisture from the ocean or sea. When it reaches the land, the moisture supply is cut off and the storm dissipates. When the cyclone crosses the coast, because after that the landmass starts, so the place where tropical cyclone crosses the coast is called the landfall of the cyclone, meaning the power of the cyclone naturally decreases because the supply of moisture is cut off.
What if
Mama, I have a question.
Okay, yes, Abraham.
Ma'am, cyclones are called hurricanes, right, in America, as per they said. But there are some like that come on land and then they suck up all the, and then they like pull objects together, like you've seen.
A tornado.
Yeah, ma'am.
Yes.
So how
They
is
are
it
known as.
to come on land?
Ma'am, I can't hear you.
Ma'am, we can't hear you.
Ma'am, I can't hear you.
Ma'am, nobody can hear you.
Ma'am, you're not audible.
Can you all hear me now?
Yes, now it's much better.
Yes. Just give me 1 minute. Okay. Right. So, what happens on the land too, due to the change in the air pressure, the the areas of low pressure and high pressure is created, and it takes the form of a hurricane. Not a hurricane, of a tornado that happens on the surface of land. Okay, on a land. All right. Hope the part where how the air pressure takes place, how the warm air is rising, the cool air is coming to take its place, and how they are rotating in a circular direction. That is ultimately creating a cyclone. Hope that is clear to you.
Yeah.
All the zones and everything.
I have another question. What's the
Yes.
difference between hurricane, cyclone, and tornado?
Hurricane, cyclone, and tornado. Hurricane and cyclone are the same thing. They occur in the sea. Okay. The rising up of the warm air and the cool air coming to take this place, that phenomenon is happening in the sea. Okay, which creates areas of low pressure and high pressure, due to which takes the form of cyclone. Ultimately, takes the form of cyclone if it's too much pressure. Okay, that is in the sea. But in the case of a tornado, that is happening on a land. Okay, this phenomenon of low pressure and high pressure takes place on a land. Okay, so on the land, have you all seen with some videos and all of a tornado? Have you all seen that?
Yes.
Yeah, I saw one and it just ripped the house in half. And the people
Yeah.
were on two sides, and the house was very long. And the tornado passed through the center, but they were on the other two sides, so they didn't get harmed.
It ripped the house in two. Yes, because the wind comes in a very great pressure. Like such strong winds come, they are rip out the trees and the houses and everything. Okay. So yeah, that happens on a land. When it's happening on a land, it's known as a tornado. Okay, but when it's happening in a sea, in an ocean, okay, in coastal regions, they are called hurricanes or cyclones. Okay. Anything else? Any other doubts?
Yes, ma'am, question.
Yes, Anaya.
So the video said that once the cyclone or hurricane comes onto land, it loses its power, right? It loses its pressure.
Yes. Yes, it loses
So,
its pressure.
so then, ma'am, how does a tornado not lose the pressure? Why is it built? Does it also come from the sea only, or is it made on land?
tornado is made on land. Okay, a tornado is made on land. Okay, that is why it doesn't loses its pressure, but the cyclones they are formed in the sea. That is why they lose pressure. Okay, and tornadoes are mainly formed in a thunderstorm. Okay, thunderstorm. In the conditions of a thunderstorm, a tornado takes place because it has a thunderstorm creates those conditions of the formation of tornado, the high pressure, low pressure conditions. In the cases of like mostly this happens then in the cases of thunderstorms, a tornado is created. Okay. If you've seen in videos, the sky is black and the big cloud is above, and then the tornado is going here and there. That you've seen. So the big cloud above in the dark sky, that is all a part of thunderstorm. Okay. So what's the difference between how a tornado is formed, cyclone is formed? Yes, if you cut off the moisture in a cyclone, cyclone stops. That's right. Okay. And how do you stop the tornado? Um, see tornado, it has a region of low pressure and the surrounding regions of high pressure. When the surrounding regions of high pressure, when that is reduced, okay, when the high pressure is reduced, the tornado stops. Okay, the tornado will reduce.
I didn't get it.
You didn't get it. Okay. See, tornado, when it's spinning, spinning, all the spinning, all the air that is there, which is spinning, can be clockwise or anti-clockwise direction, depends on the hemisphere. The way it's spinning, the spinning portion of it is at a very high pressure. The air there is at a very high pressure. Okay, what can happen is that pressure, when it is decreased, okay, when the pressure due to the change in the atmospheric conditions, when there is decrease in that pressure, the tornado also starts to um, deplete. Okay, the tornado also starts to deplete and then ultimately it stops. Okay, get it now?
Yeah.
Yeah. I'll find um, a visual like representation to explain this to you, the formation of a tornado. Okay. Wind, basically, it's the movement of wind that plays an important role in forming all of both a cyclone and a tornado. Okay. And like when the wind is moving in different speeds and different directions, also at different altitudes, it causes the air that's rising up to start spinning. Okay, air that's rising up to start spinning. This spinning takes a form of a tornado, okay, and creates a condition of high pressure. All right. Yes. So we have finished with some natural disasters, and next topic that we are going to cover. Let me see. I think it's the earthquake. Okay, earthquake we have, and its causes. All right, the internal structure of the earth we have, and then how the movement of the land takes place in an earthquake. Okay, that thing we are having. So we will cover this in the next class. Okay, we are going to cover this tomorrow. Okay, I'll try to find also a representation of this thing also, like how the actual movement of the tectonic plates, of the plates inside the earth, the layers, how they are moving, okay, causing an earthquake. Okay, we'll talk about it. We'll study about it. Tornado warning safety measures. Okay. Yes. So, can you read them out loud, Simran? Once? Unmute yourself and read them out.
Avoid areas with many trees. Avoid vehicles. Lie down flat in a gully, ditch, or low spot on the ground. Protect your head with an object or with your arms. Move away from windows and glass doorways. Go to the innermost part of the building on the lowest possible floor.
Yes, on the lowest possible floor. Why does it say to lie down flat in a
This is during when? This is during an earthquake.
This is a tornado during a
During
tornado.
tornado.
Oh. But then didn't you say, Simeon, that it'll rip apart the buildings? So how's it gonna help if you stay? And again, unless they're tornado proof or something. Like those
It
type
will
of
rip
buildings have come
apart.
up in Japan.
Mhm.
Those type of buildings have come up in Japan. But like, yeah, how do you stay in the building if
So,
you just so the tornado will rip it apart?
so it's like you go underground, like under the house, and then there are these tornado places inside the building underground, and you go inside that, only the building will be carried away, but the whole inside will not be affected.
That is right. If you were underground, okay, it'll
Ma'am,
help. Why? Because yes, Abraham.
I have one question about the underground, ma'am. What if the tornado rips up the building and then the passageway to the underground is ripped and somebody standing under the passageway will also be ripped up?
It'll also be ripped up. See, Abraham, the tornado has its low pressure point beneath it. Okay, like the below part, okay, of the tornado is low pressure. Okay, if you see inside the innermost and the last part of it is low pressure, so wind speed is lower there. But the things that are coming in contact with just the regions of the tornado above that point, that is the house, the big house, the two-story house. If the tornado surface comes in contact with the house, the surface of the house, the whole house, it can rip apart. But the lowest point, the part below the house, that's underground part, it won't. Okay.
So, ma'am, if I'm living in the first story, the tornado won't affect me, right?
If you are in a first-story house, then it will it will have some effect, definitely. Yes, that's right. But
If you're
it may
underground, it won't have
cause,
that much effect.
yeah, it's not that much effect, yes. But may some effect it may cause. Okay, like the doors and windows will bang. Okay, that's why they say to stay away, keep away from doors and windows. Okay, the measure says that.
And
So
because glass can easily shatter and then
yes,
cut also.
yes, glasses can easily shatter.
Can a car fly away in the tornado?
Yes, and yes, a car can fly away.
Is he sitting in it?
That's why they said avoid vehicles.
Yes, avoid vehicles. Definitely, a car can fly away. It's comparatively lighter, and if car doesn't has anything to hold it on the ground, right? Our houses have a foundation that is beneath the ground, right? But cars, they are lightweight as compared to the house structure, right? As compared, they are like cars are very light. It can fly away in a tornado.
So, ma'am, if I'm in the car and I'm slow and my car got stuck to the tornado, I'll still be safe, right, ma'am? Because I'm in a car.
You are in a car, no, you will fly away with the car.
Yeah, but I'll still be like, because mostly
No,
people
you won't because the car will be crushed.
due to
The car will
debris that is there. So,
see,
if I'm in the car and the windows are shatterproof, then I will be safe, right, ma'am?
no, car will be wrecked, okay? Because the winds in the tornado is at such a high pressure. They are moving in such a high pressure that, and then there are other objects also that will be flying inside the tornado. Woods and everything will come together, they'll bump in each other, and your car will be like due to that pressure of that such high speed winds. Okay, the car will be wrecked.
What?
The pressure inside is lower than the pressure outside. The car will be crushed also.
The car can be crushed. Yes, the car can be crushed
So I have
also.
to keep my windows open.
No, your
If you
windows
put
will
a-
break.
The windows will break also, and then the things that are other things that are inside the tornado, like wood and all.
You just can't be inside a car, Abraham, during the tornado.
Will a submarine work?
No, the submarine also won't work.
A submarine will work, ma'am. It's meant to stand a high pressure.
Yeah, actually, submarine might if it's like built that way.
If it's built
And
well,
submarine goes pretty low. I don't think the cyclone reaches that place. Goes like thousands of feet beneath the sea.
No, ma'am. So the submarine should actually just work.
if you put the submarine on land, because tornadoes are coming on land.
So, ma'am, then we can add a set of wheels.
A set of wheels. Okay.
Abraham,
That
you
is
should become an inventor when you grow up.
kind of
Make the
imaginary.
first submarine with wheels.
Okay. Yeah, so we stop here today. Okay, tomorrow we'll cover the earthquake portion. Okay, we will be covering the earthquake
Just
portion.
one question: what happens what happens when the submarine disperses in the storm? Like when the storm disperses, like the tornado is over, does everything just fall on the ground?
Does everything fall on the ground? A tornado, when it's over, yes, things fall on the ground. The wind also just disperses. Okay, the wind disperses, leaving behind all the wreck that it caused. Okay, leaving around the wreck that it's caused. A submarine safe in storms, immune to strong winds and high seas, but 100 years ago, the British vessel HMS Airline fell victim to typhoon. 19th August 2004, submarine flotilla based in Hong Kong harbor, 20-meter vessel had a crew 30. 4 sailors were on board. What does it mean that only 4 sailors were on board at the end part of the fourth submarine flotilla based?
Simeon, you're not counting that the remaining of this 69 soldiers died out of shock.
Okay, so if you all want to do a case study in the holidays, if you want to do case studies on storms, on earthquakes, case studies is basically, and you pick an incident, okay, you study about it, you go through its articles, you can read
And you
on
make
it
a
on
report
the
on
web.
it, right?
Yes, a case study you can go through, make a report on it. What to include in the report, I will update you. Okay, in the group, I'll update you that you can include how when it happened, what was the reason behind that natural disaster. You can pick any. You can pick a cyclone, a tornado, a flood, or an earthquake. Any natural disaster you can pick. Okay, and what was its cause? What was its effects, and how they overcame the effects and everything. What regions it affected. Okay, all that you can do. Like in the holidays, I can give you this thing as an assignment.
So, ma'am, will that be our activity for October?
Will that be your yes? It will be your activity for October. Okay. Now,
Ma'am, one last question about tornadoes. If I'm in a tornado, will I be thrown down after it stops? Will I be lightly put on the ground?
Will you be thrown down after it stops, or will you be lightly put down on the on the ground? I think not very, very lightly, but also not thrown down when it stops, okay? Because when a tornado is stopping, the wind speed decreases slowly. Slowly, the wind speed decreases. So yes, you will be thrown down, but not at a in a speed,
So, ma'am,
okay?
enough survive.
Abruptly. Survive, that's hardly possible, Abraham. Okay, because inside the tornado is like a lot of things there. It's a high pressure winds there. Our body might not be able to bear that amount of pressure of wind.
Our ribs will collapse.
Yes, probably, yeah. We'll be unable to breathe, and then the pressure, our body won't be able to bear. Okay.
So the best thing to do when there's a tornado, stay underground.
Stay underground. Yes, that's the best thing. Take shelter at low-lying places, because at low-lying places that is lowest pressure. Okay. Okay, so that's it for today. Okay, we'll stop here, and tomorrow we'll continue with earthquakes.
Today's class is kind of fun.
Yes, it was fun. All right, I'll update the report homework on the group, okay, in the next couple days.
So it's
I'll
going to
update
be like a homework time.
homework for today. Report homework is for the holidays, okay? You can take your time, browse through good disasters, good articles, and everything. That's for the holidays. Today, just give a read to the portion that we covered already from this
Okay.
chapter. Okay, that's it.
No, I'm asking about the natural calamities. Will you be like asking us to read it out or something?
Will I be asking what? Can you
I
repeat
mean,
your
is it
question?
like an optional activity or we can choose not to do it also?
Do you all not want to do it? Like, I think it's an interesting activity, and I highly suggest you should do it.
What's the
Okay?
activity? I didn't hear.
Oh, singing. And okay, activity was to study about any natural disaster of your choice, a real time when it happened. Okay, um, you have to read about it. Okay, and then I'll
Like
be giving
natural calamity could also be like an iceberg, like
not really
things
an
like
ice.
that.
Natural disaster, actually a disaster. Okay, it should be actually a disaster. You can take thunderstorm, you can take cloudburst. Okay, but it has to be a disaster, disaster thing. Okay, so I'll tell you what points to cover in the report. Okay, like how the disaster happened, what was the aftermath of the disaster. Okay, what like what damage happened to the people, okay, to the nature and everything, okay, and what preventive measures can be taken to avoid such disasters, to be safe in such disasters. I'll make those points, what we have to include in the report. First, you read about that disaster in an article or on the web, okay, read about it, search some images also you can put, okay, to make a report and then submit. Okay, in class also, I'll give you time to present it, like a short time to tell about your report, what you prepared, what you studied, what you saw, what you observed. That session also we will keep, okay, 10 to 15 minutes. You can just tell in the class about it. This is the activity for like this month. Okay, I'll update all the details and in writing on the group so you can go through it. All right.
So we just have to make like a
Report. Excel, Microsoft Word, Excel, you can use. Okay. Those things you can use for it. Also, you have to present it in class too. Okay. After the holidays, this will be. I'll take it after the holidays are over. Okay. Next week you'll have it.
So you're going to ask us to present it.
Yes, you can present it. In short, you can present it.
Okay.
What you have right? What you learn,
Okay.
what you
And
observe.
minimum how many words does it need to be? Like, is there any word limit?
Word limit. Word limit, I'll post it in the group, okay? I haven't decided of a word limit,
So you'll
but
post everything in the group?
Does there have to be a word limit?
I'll post it. Simeon hates word limits. No, Simeon? Okay, I'll keep a word limit, maximum and minimum both.
Okay.
I'll give you a minimum and maximum word limit, so you can keep it to the minimum also in between that minimum maximum also.
Alright.
Okay?
Alright.
Okay. See you all then. Bye.
Thank you, ma'am. Bye.
Bye,
Bye.
Simran.
Bye.